eigenvalues and eigenvectors. So we started the discussion just by asking this because this is something which you might have also learned earlier. As I again repeat, we will go through the same thing. What is eigen? Still, do you recollect the meaning of the word eigen? What is the meaning of eigen? Eigenvalues. So, if you go through the dictionary meaning of eigen, what is their meaning? What is the meaning of the word eigen? तर प्रॉपर ते असल्या गुगल सर्च असल्यामुळे आता सगळ्यांना सगळं कळतंय. प्रॉपर किंवा कॅरेक्टरिस्टिक. आता त्याचं हे पण दिलेलं आहे. आता अजून नंतरच्या का चॅट जीपीटी वर बरंच काही येईल. तर आता हे वाचल्यानंतर तरी कळतं का बघूया. ए व्हेक्टर विच म्हणजे आता what is eigenvector? A vector which when operated by a given operator gives a scalar multiple of itself. आता ह्याच्यावर आपण हे घेऊया. We will build up the entire discussion based on this single sentence. म्हणजे eigen, what is the meaning of eigenvector? A vector which when operated on by a given operator gives a scalar multiple of itself. So we work with vector म्हणजे multiple dimensional आली. Some vector we take a 3-dimensional. Take a 3-dimensional, some vector. When we say vector, what is a vector? It's an ordered combination. It's an ordered combination. So we say x, y and z. A vector when operated upon means this vector, how many rows are there? 3 rows. How many columns? 1 column. Right? The result is its scalar multiple. Lambda x, lambda is 1 scalar multiple. Just as is being used. So lambda x, lambda y, lambda z. When operated upon, I operate it, I can operate it by 3x3 matrix. By 3x3 matrix. So this is A. A is a 3x3 matrix. Now this eigenvalue, this is having various applications. If you just go through linear algebra and especially the notation and is so boring that you hardly find will it be of any use to me other than it's a simple subject for 3 credit course and will give me good grades. Other than that, one may not find its application. But this eigenvalue and eigenvector module is somewhat simpler to understand, and the notations are not also that much clumsy. There is some clarity and is having application also. So a vector 3x3 vector, a matrix 3x3 matrix operates on a vector. Means now this is operating on a vector. Means and it should be scale. Means what we should have? There are 9 terms, something into this, plus something into this, plus something into this. So what should happen, that this uniqueness eigenvalue is its own eigen जे मूळ स्वरूपाचं कॅरेक्टरिस्टिक त्याचं मूळ स्वरूपाशी निगडीत आहे. म्हणजे प्रॉपर हे सुद्धा प्रॉपर इज नॉट ए द वर्ड प्रॉपर आयगेनचा अर्थ प्रॉपर म्हणलाय पण तो ते अगेन दॅट इज नॉट ए व्हॉट वी कॅन से प्रॉपर सिमिलॅरिटी. सो इफ वी राइट इट हियर दॅट a11 a12 a13 a21 a22 a23 a31 a32 a33 a11x plus a12y plus a13z must be equal to, just right, because it is means just like in mathematics you will find there is something unexpected, some magical thing happening. Say if we talk of Pythagoras, the theorem that the squares of two sides match the squares of the diagonal, we find something which is magical, like that a11x plus a12y plus a13z should be lambda x, lambda times x. Similarly, a21x plus a22y plus a23z should be lambda y, and a31x plus a32y plus a33z should be lambda z. This is obvious if a11 a means if this matrix is lambda 0 0 0 lambda 0 and 0 0 lambda. If this matrix means what we say that yes, this is possible provided a1 equal to lambda, a12 and a13 are 0, a2 equal to lambda, these are 0, a33 equal to lambda, these are 0. So if all non-diagonal elements are 0 and diagonal elements are lambda, then for that it is quite obvious. So that then means for a diagonal, for a matrix which is only having whose non-diagonal elements are 0, for a matrix whose non-diagonal elements are 0 and diagonal elements are constant, for that it is instantly satisfied. But the question is whether it exists even when non-diagonal elements are non-zero. Even when non-diagonal elements are non-zero. So this is for 3 by 3. I will come one step down, and for 2 by 2 we shall elaborate in detail so that we may understand something to a large extent. So this you keep as it is for latter part. We go for simpler one, that a11, a12, a21, a22 is matrix A. This is X. When we say X, we don't write X, Y, Z. We say matrix X. So we write X1, X2. We make a small change. It's not wrong, but to be very precise, we should write X1 instead of X, Y, Z, X2, X3, because we write vector X, right? With X. So this will be lambda X1, lambda X2, lambda X3, now we try to go through. Into x1 x2 is equal to lambda x1 lambda x2. Now what does it mean? A11 x1 plus A12 x2 is equal to lambda x1, and A21 x1 plus A22 x2 should be equal to lambda x2. Means what should we have? How will you solve this now? How will you solve this? Is it right? So just forget. No need to forget if only if you remember. Otherwise, there is no question. And try to look at this problem from a novice angle. Sometimes, if you look it from a fresh angle, while solving, you may get some additional instinct. So how will you solve this? How to proceed? Just find out lambda and x. Okay, sometimes we find that working on some variables like a11 makes it somewhat, what we can say, tedious. So you can work on values also. Or instead of this, earlier I told you, if the matrix is a diagonal matrix such that whose non-diagonal terms are 0 and diagonal terms are equal. So what we can say, I can always say that lambda 0 0 lambda into x. Am I right? Is it okay? Is it right? So for lambda x1, lambda x2, I write this. Is it okay? So if I write this, what happens? It becomes somewhat easy for me now. Now what you can do? You can take this term on the other side. This you are saying anyway as A. This is x. This is lambda I, and this is x. So you can say that, or this you can use as it is A11, A12, A21, A22. This will go on the other side. Some matrix into x minus other matrix into x is A11 minus lambda, A12, A21, A22 minus lambda into x1, x2 is equal to 0 matrix. Is it right? So it is, this is A minus lambda I. This is a square matrix A minus lambda I. So what we should get? A minus equal to one matrix into a vector yields a zero vector. What I should get when that is possible? A minus lambda equal to 0 means this 0, this 0, this 0, this 0. If all are 0, then you get this A11 is lambda, this is lambda. What? Determinant of this is 0. So A minus lambda determinant is 0. So the determinant is 0 means A11 minus lambda into A22 minus lambda minus A1 A2. Right? A11, so what we should get? Should get as A11 minus lambda into A22 minus lambda minus A1 minus A12 A21 should be equal to 0. So we get lambda square minus A11 plus A22 lambda minus A12 A21 must be equal to 0. Is it right? Is it okay? So what we do, so it becomes a quadratic equation. So a good quadratic equation, we are aware of lambda square minus 5 lambda plus 6 equal to 0. What the solution is? Lambda minus 3, lambda minus 2. Right? So we try to have that. So what we can have? A11 equal to 2, A22 equal to 3, A12 equal to, what we should get? Anything will do. So this matrix A112, A126, I think we have made some small mistake there. A11 oh, we missed one term. What is that? It's plus, no? Right. So we can have we can choose. We can choose the equation to be lambda square minus 5 lambda plus 6 equal to 0. So A11 you can choose 3, A22 you can choose 2 and 3. This is minus A11 A22 minus A12 A21. So A11 A22 is 6 and this should be minus A12 A21. So this must be, so again it becomes minus that, this is 6. Then this should be 0. In that case, again 0, 0 is proper? Yes or no? So minus 2 and minus 3. And then lambda minus 2. So again it becomes very simpler. We take it take the this is 2 and 3, so we take the values, we took the same value, we want A11 plus A12 should be minus, A11 plus A12 should be equal to 5, so we should take 1 and 4. If we take 1 and 4, then this becomes into 4 and this should be 2. So when this we want to be 2 and so A1 minus this means this should be minus 2. So A12 is minus 1. Is it alright then? Is it okay? So lambda values are 2 and 3. Lambda are 2 and 3. So means for lambda equal to 2 and lambda equal to 3, there exists, means it is not that for any value of vector it is true. There is an eigenvalue of 2 for lambda equal to 2. There is a peculiar vector x for which A into that becomes 2 times this. So A it becomes like this. So this we have got x1 minus x2 and 2x1 plus 4x2, that should be equal to 2x1, this should be equal to 2x2. So when we get this for what? What do we get? x1 equal to x1 equal to minus x2, right? Is it right? If we solve these two, what we get? x1 goes on the other, x1 equal to minus x2. And the moment at which you put x1 equal to minus x2 is also valid. Is it right? So x1 equal to minus x2 means you can write a minus a. For lambda equal to 2, a vector of a minus a a vector A minus A is eigenvector such that for this matrix A into X which is of the type A minus A leads to, this results into 2A minus 2. And for lambda equal to 3, what will happen? For lambda equal to 3, for lambda equal to 3, what you get? You just put as 3. So what you get? For lambda equal to 3, what is the relationship? For lambda equal to 3, what is the relationship? What is the answer? हे येते का बघा इथं यात सुद्धा एक टाकून बघा. मग असं 1 minus 1 2 4 A minus minus A 2A minus 4A minus 2A.